So we have Maxwell's equation. We've got this in terms of the Ford potential, and the Ford potential is a more compact form of the electromagnetic field. It's more compact because it has less degrees of freedom. If we look at our electromagnetic tensor, we can see that it has two indices. It has 6 independent degrees of freedom because it's antisymmetric. It's quite clearly antisymmetric between the alpha and beta indices here. And those 6 independent degrees of freedom we used to think of as the electric field and the magnetic field as 3 vectors. But in fact, we can get all of that information down into one 4 vector because this tensor here has to obey Maxwell's equations. And so in fact there was redundant information in here which we could boil down. So the question is, have we gone as far with that as we possibly can? Is this in fact the one true unique electromagnetic potential, or could we change even this again? And the answer, much like we had with the Lagrangian, was yes, we can change it in particular ways, although we don't end up losing any dimensions, we just have some freedoms. And these freedoms are called gauge freedoms because we make what's called gauge transformations between different potentials. And much like the Lagrangian case again, the gauge freedom we have is where we take our field and we can add the derivative of any other field, and all our physical predictions are unchanged. In other words, that 4 potential still will obey Maxwell's equation, and it will still produce the identical electromagnetic fields, which will give us the same 4 forces. So go ahead and show that.